So what is retinoscopy? This is a very hard skill to learn. I mean, this is hard. First year opto residents are terrible at it. Second year, you're getting better. By the time you're a third year resident, hopefully you're quite good at it. Very useful skill, but the idea is you're using a light and shooting light into the eyes to get an idea of what the reflection looks like in order to estimate glasses prescription. Very useful in people who can't talk, maybe demented patients, and certainly in young children who are pre-verbal. So this is the machine we use. This is called a retinoscope, and a retinoscope is basically just a light, a little beam splitter inside of it that you look through, and you shine this light in your patient's eyes, and you look at the red reflex and how that red reflex moves in order to get an idea of what the prescription is. So here's the theory behind it. Now this is an eye, and if you shine a light into an eye that is in perfect focus, i.e. is not nearsighted, is not farsighted, the light will hit the back of the retina at a single point, hopefully the macula, and the reflection will come back out of the eye, and you can move that light up and down or whatever you want to do. The reflection stays stationary. Maybe that doesn't make sense, so let's try a different eye. This eye is not strong enough. When you shoot light into the eye, it wants to focus behind the eye. And as you move your light up and down, the reflection bouncing off the retina also moves up and down because it's kind of pivoting way behind the eye. So move your light source up and down, the reflection coming off the retina also moves up and down. So we add a lens on here, a little bit of strength, a little bit of power, not quite strong enough yet. As you move your light up and down, once again, the retina reflex is going in the same direction as your light source. So you make a bigger lens, and now the eye is in perfect focus. As you go up and down, it hits that single point, and you have the perfect red eye, or the perfect red reflex. If you put too much power in front of this lens, let's say you hold up a really strong magnifying glass like this, then things want to focus into the middle of the eye, right here in the middle of the vitreous cavity, and your reflection coming off the retina is going in the opposite direction. It's kind of pivoting. There's a seesaw action, and you've gone too far. So using this theory, by holding different lenses in front of the eye, you can play around with the reflection as you move light up and down and hopefully figure out a prescription this way. So, what does this look like? Now here's our light. As you pass in front of the eye, you can see that red reflex back there is the line that you're seeing in the background. It's inside the eye, and it looks a lot like the light source, and it goes in the same direction. So we know things aren't in focus. And it doesn't matter what direction you move your light. In this case, it's always going in the same direction. So that's what we call with movement. So let's hold up a +1 lens, add a little bit of power, and the reflex is still going in the same direction. So we're not quite there yet. You notice that the red reflex, that line back there, looks a little bit thicker than it did before. So it's gotten a little bit bigger, but we still have with motion. Not quite what we want. So that's at a +2. That light's still going with, so it's not quite there yet, but you notice that that red reflex has gotten bigger. So we're getting somewhere. Something's happening. We're getting closer to our ideal, perfectly focused situation. So let's try +3. This is it. You notice that the whole eye lights up as soon as that light gets over the pupil. This is the perfect focus, and this is the right prescription for this eye. If you go too far, add too much power, then it focuses in the middle of the eye, and you get that seesaw, that against motion. So if you've gone to against, you've gone too far. So in this case, a +3.00 lens was the right prescription for this eye to get it in perfect focus. Now there's a little bit of a correction factor depending upon your working distance, but this is how we figure out prescription in young kids. So you have a 18-month-old kid. You're trying to figure out if they are nearsighted or farsighted. This is how you do it. You hold up lenses in front of them. This is a rack of lenses, the kind that we'd use on a kid. And you basically just keep holding up these lenses in front of the eye and checking that red reflex until you get exactly what you want. If you have an adult, you can use a lens rack like this, a retinoscopy bar. This is nice in adults because you don't have to constantly switch lenses in order to find the right one. It doesn't work well in kids because kids don't like having this big giant thing in front of their face. They're constantly wanting to grab it. So with kids, you end up using loose lenses. So retinoscopy, an incredibly difficult skill to pick up, but very useful with both pediatrics and with adults. All right, next topic, ocular misalignment.